This is a University of Lethbridge Department of Mathematics and Computer Science 2610 video by Nicole Wilson. This is the Lab Exercise 0 Sample Lab, Question 1a. Question 1a says, question 1 asks us to consider the Boolean expression x NAND y or x naught and y naught. In part A, we're asked to make a truth table for this Boolean expression. We're instructed to have across the top of the truth table the columns in the order x, y, and then the final outcome. Any necessary intermediate columns should appear between the y column and the final output column, and the rows must be in standard order. So here's where we're going to type our answers. I'm using Word because it is available to everyone at the University of Lethbridge through the portal. And because out of all of the PC stuff that's available, this one is the easiest to do math mode in. If you are working on a Linux box, there are various other options. Ultimately, we don't care what you use to make these documents, your lab exercises. What we care about is that in the end you save them as a PDF before you hand it in. So we're making a truth table for, as I say, it's easy to go into the equation editor here. You hold down Alt, hit the equal sign, and we're doing x NAND y or not x and not y. In the equation editor, we have the ability to type things in equation form. There are menus for most things. If, for example, you needed this union symbol, you could just type /cup, which shows up here at the top. You don't need it for a lot of things in this course, but it is available. Again, I'm going to do things in math mode here, so I'm going to make a table using the matrix. We need to have a column for x, a column for y, and then for any intermediate things we want. So in my case, I'm going to do a column for x NAND y. Then I want a column for not x, so I'm going to insert a column after, and one for not y, and one for x, not x and not y, and then one for my final expression. As for number of rows, because we have two operands, x and y, to get every possible combination of zeros and ones, it's always for n operands to the n rows. So we're going to need, besides our title row, another 4, 2 squared. I've only got 2, so I'm going to insert a couple of rows here. The way I'm doing this is not the most efficient way. What I actually tend to do when I'm writing up my own answers is make one of these big blank ones and then copy paste it rather than retyping it every time the way I did here. But you have to do it once if you want to use this. So then again, this is going to be x NAND y or not x and not y. We want the entries in our input operands here to be in numeric order using zeros and ones. So a quick way to do this is to make the first column half zeros, then half ones. So 0, 0, 1, 1, and then I call this having the pattern. So instead of 2 zeros, 2 ones, we do 1, 0, 1, 1, and so on until we get to the bottom. So 0, 1, 0, 1. It's not a huge deal in a truth table that's only going to be 4 rows anyways, but there you go. So we know x and y is only true when both our inputs are 1. X NAND y is only false when both our inputs are 1. So we've got a 0 there and a 1 everywhere else. Not x, just flip the zeros and ones on x, so we get 1, 1, 0, 0. Not y, same sort of idea, flip the zeros and ones on y. And then when we AND them, the only time that we're going to get a 1 is in that first row with the 2 1s, and all the rest will be zeros. Then when we OR these together, ORs carry the 1s through, so if there's a 1 in a row, it's going to be a 1 on the output, regardless of which of the operators have that, or operands have that. The only time we get a 0 is when both inputs are 0, which is only in our last row. So we end up with 1, 1, 1, 0. And that is the truth table for this question.